Hello and welcome everyone. A reminder that before you watch this walkthrough, pause the video and try the problem for yourself. Even a partial attempt will make the explanation that much more valuable. These videos are meant to support your problem-solving process, not be a replacement for it. Across different practice problems, I highlight different aspects of how to approach, break down, and reason through problems. So you're going to get the most benefit by watching multiple of my walkthroughs rather than treating any single video as a template that you can copy. With that, let's get started. We're going to be working on the practice problem, rotate left today. Given an integer array, calling it R, and a non-negative integer k, let's return a new array where the elements of R are rotated to the left by k positions. You may do this in place in a void method if you prefer. And when I show you the two different solutions, I'll sort of draw out both possible solutions, but I actually will only be coding up the one where we return a new array. Rotation to the left actually means that elements shifted off the beginning of the array will reappear at the end. If k is greater than the length of the array, we're going to rotate only the effective number of times. And we'll talk more about what that means when we get there. An example is shown right here with an input array, 1, 2, 3, 4, 5, and a k value of 2. And what we see happened is those two values shifted left, and left being off the array and back around. So it wraps them back around and shoves them on the end of the list. It's a bit like being booted to the back of a line. So it booted 1 to the back of the line, and then it booted 2 to the back of the line. Now, before we actually jump into the code, I'm going to do some drawings of this just so that we have a really good handle of what the heck this question is asking us to do. Okay, so I find it really helpful when we're about to approach like a problem that has some pretty classic problem-solving elements to it, to actually draw out what is expected to happen, and it can really help us understand the steps that we need in order to solve a problem like this. So let's just take the example, which was 1, 2, 3, 4, 5 in our array, and we had k equals 2. And we understand, hopefully, that, I'll just put this down here, that after this is done running, after the rotate left function of array and k, we would end up with 3, 4, 5, 1, 2. Now, I have two different ways that I can sort of see how we would solve this problem. So I'm going to walk through both, and then I'm going to solve one in code, and I'll leave one up to you to try to solve. So the first one that I see is a literal rotate. So we would basically go through the following steps. We would grab the element at 0, and just like an insertion sort, shift, oops, I should do it in a few steps here. Shift all elements forward, and then we would insert the element from step 1 into array. Oh, it's named like that, array at length -1, right? And then we would do all of this k times. So what I see happening is the first time through, we would be grabbing, the first time through we would grab this 1, we would shift this here, this here, this here, this here, and we'd put the 1 right here at the end. So we would go from our initial array of 1, 2, 3, 4, 5 to 2, 3, 4, 5, 1. And then I said we were going to do it k times, so we'd have to do it again since k was 2. We'd once again grab that initial element right here, and we would shift everything over by 1, and then we'd pop it in at the end. And after k times, we'd have that resulting final array. And that's one way to solve this problem. Now, that makes sense because that is pretty much how it's described in the question, right? We're talking about shifting that many elements to the back. Now, there is another way to think about this problem. The one that I just showed is the one I'm actually not going to code up because that one can be done in place, and that's a nice little challenge to leave for you to try. Now, the solution I will show is going to be one that is not done in place. So if you want this written down, now's your chance because I am going to delete these. I'm going to erase these steps. Let's go ahead erase them. Oops, of course I erased part of my array there that I didn't mean to do. There we go. And let's just check this out one more time. I guess we can leave this there because the question is, how else could we do this? And the other way to imagine this is if k is equal to 2, we're going to take the first two elements and just plop them into the last two spots, right? So take k first elements, shift everything, and then plop k first into k last. Not even a shift necessarily, because this one we're going to do not in place. So we'll take the first k elements and like store them somewhere, like just hold on to them for a second. And then we'll move k plus 1 up to length minus 1 into spots 0 to n minus k. And then we can plop our k first elements into the k last one. Now, why did I say n minus k? Well, that's because n is 5, and k is 2, and that's 3, and that is the number of elements that need to show up in the front. So we needed to take those last k plus 1 to length minus 1 elements, which was the last 3 elements in our example, and we needed to plop them into spots 0, 1, and 2, instead of them being in 2, 3, and 4. I wrote stop, but I meant into spot. There we go. So let's imagine for a second in this example, 1, 2, 3, 4, and 5. First thing I would do is I'd probably try to make a new array. And this new array will just hold the first k elements, so 1 and 2. This is hold first k elements. Then I'm going to also have like a shifting array, shifted. And this needs to be the size of the original array. There we go. So that this is going to be like my final answer array. Final answer array. Okay, and so now what I'm going to do is I'm going to do exactly what I said. I said take the last n minus k elements and put them in spots 0 up to n minus k. So that would be copying this into here, and this into here. 3, 4, and 5. Perfect. And then once that's done, I can go ahead and do my step 3, which is take my new array, holding first k elements, and fill shifted. So I can take this one and put it in the next available spot, and I can take the 2 and put it in the next available spot. And as we can see right here, we end up with the right answer that we had originally as well. So 2 different solutions. One was moving one by one. One is more of a collection and shift all at the same time. Neither are more correct. One is a little bit more efficient than the other, but we're not terribly worried about that right now. Okay, so now I'm going to switch over to code, and this one right here, this is the solution I'm going to show in code. And once you've got a good handle on it, I strongly recommend you head over to this, the previous example that we had. Oh, not that one, the one I erased. You go back in the video and try and solve it in place as well. Today I'm going to be using Sublime Text instead of a proper IDE. This will just take away a lot of the like IntelliSense and AI that I have access to when I use Visual Studio. You can continue to use Visual Studio, it's totally fine. In my previous video, I showed you how to use the terminal. And so there's really no reason for me not to just use the terminal and use my preferred text editor, which is Sublime Text whenever I'm doing these types of problems. So just a heads up why it looks a little bit different. But just like the previous ones, I am copying everything in. Now, anytime you're being given a problem, whether you're in an interview or in like an assignment or something, you should try to think about it as much as possible in methods. So being told that we're being given an array R and a non-negative integer, and we need to return a new array, that tells me I need a method. So I'm going to go ahead and make one right down here. A public static, I return a new array, it says, and we are doing that rotate left. We're told we're taking in an integer array. We can call it whatever we want. And we need to take in that value k. All right. Now, whenever I get started, I like to think about sort of like my edge cases first. Because I know I have to have a return value, I'm going to ask myself, what the heck will happen if my array is null or if my array is empty? And because it doesn't tell me, I mean, the first thing I should do is probably ask, right? If you're in an interview, you ask your interviewer. If you're in class, you ask your teacher. I'm going to make the decision here, and I say that if the array is invalid, return null. And that's perfectly reasonable. So if my array is null, or my array is invalid because the length is 0, we're going to have a return null. So I'm going to need my new int array, call it shifted, and we'll just set shifted to null in here. Now, hopefully you'll notice that I did give my shifted array a declaration and this value. I assigned it the value of null. And then in here, I also made it null. And then I could just say else solve problem. This right here is pretty redundant, right? It already equals null. I don't need to reset it to null. So what can we do to make our code a little bit cleaner? We can just actually negate our if statement. When you negate your if statement, you have to negate these, and you need to negate this. So an or becomes an and. So we end up with, if the array is not null, and our array.length is going to be strictly greater than 0, then we need to solve the problem. Otherwise, we're going to do nothing and leave shifted as null. So I've now cleaned up my little mini method here. There's not a lot in here yet, of course, but this does let me have a little bit cleaner code. Now, the nice thing with writing methods is that I can start testing right away really easily as well, right? So I can make this rotate null like this, and I can make sure that shifted is null, and I can say, oh good, it should be null. That makes sense. We want it to be null right now, and this allows me to test to make sure that my naming is what I'm expecting, it's coming in, and that this check is doing what I want it to do. And anytime I write any kind of decision-making code, I always try to write some kind of test for it. So I'm going to do that right now. We can go ahead and run this. We're passing in null, so this absolutely should return, oh good, it should be null. And that's exactly what happened. So that's perfect. The other thing I can test for is a new integer array of size 0, which also should come back as null, given the way I've written my code down here. So let's just recompile and confirm it. Fantastic. And now if I pass it an array of, let's say, size 3, well, right now, this if statement doesn't actually do anything, so it would technically stay as shifted equals null. But I guess just really quickly, we can set our shifted array based on like our drawing. We understand we need to return an array that is the same size as our original array. So I'll just make my shifted array in here so it's not null anymore, make it the size of the original array to ensure that when I now run this code, nothing should print out, right? It should just very nicely complete with nothing printing out, which is what happened. So that's perfect. So now we know our if statement is working as we expect it to, and we can move on to the actual rotation part of our code. Now, I did mention that in my original description, there was 2 different solutions. So we're going to jump right in with the solution that I outlined that we'd be working on, which is the sort of chunk swap. So we're going to have some array here, k elements, and this is going to be equal to the size of k. We're going to go ahead and move those k elements, the first k elements in array, into this k elements array. So for int I is equal to 0, Let's go ahead and add some comments, actually. This will be my returning array of original size. This array here, k elements, holds the first k elements from array. And now we can say for each of the first k elements, so we're going to go from 0 up to k, what do we want to do? Well, we want to copy the elements from R into k element. Now, I would like to say that you can use a system.array copy here, and I am making a very conscious choice to not use it so that we can see explicitly what is happening. I will put a little note here. Instead of loops, you can use system.array copy if you know how. So that would work as well. So now we've got this k elements array, and it's going to have those first k elements from array in it. What was the next thing we said we had to do when I was drawing it out? We have to copy the remaining elements from the original array, and that was going to be n minus k. That's how many elements there were, into 0 up to n minus k indices in shifted. Okay, so what does this for loop look like? Well, this for loop can look a couple different ways. I know that I need to be working through my original array starting at k plus 1. And I know that because this array right here, this loop already took care of 0 to k. So what I could actually do is I could start this at k plus 1, and I could let this loop go from I all the way up to the end of the array. That would work. And then I could make a new counter here for my shifted counter. And this one needs to start at 0 because we're going to move whatever was in k plus 1 into spot 0, whatever's in k plus 2 into spot 1, whatever's in k plus 3 into spot 2, and so on and so forth, all the way until we fill it up. So what we can do now is we can say in shifted, at that shifted counter, just go ahead and assign it whatever the heck is in array at I. And then let's not forget, we need to increase our shifted counter so that next time this loop runs, the counter will increase. Again, system.array copy would work here. Okay, so this one right here assigns k plus 1 array at k plus 1 up to array at n minus 1 into the spots of shifted at 0 up to shifted at n minus k. So we fill up the front of our array. After we've done that, we need to not forget to move the k elements array values into shifted, and that starts at n minus k plus 1, right? It starts right where we finished off there, and it goes up to the end of the array, of course. This is actually really easy for us to do because we can just go through every single element in that k elements. In fact, we can even do it in a for loop. For each element in the k elements array, we can go into our shifted array, and at shifted counter, we can put the element, and then we can just increase that shifted counter. And that will continue to count up in our shifted array as we copy over each of those elements in. Once we've completed that, shifted now should contain all of our elements from our original array, and this should work. Let's give it a try. Let's make sure that things are going to work the way we would like them to. I'm going to add a little helper method really quickly. All right, so I went ahead and just added a print method for myself, and then right up here, I've created the array that we already know how to use from our previous example. I'll print it out so that we can see it. Then I'll call shift on it with an array of size, with a k equal to 2, and then I'll print my shifted array. So let's go ahead and compile our code, make sure it works, and then we can run it. And let's see what we've got here. So what we have is we have our original array printing properly, but oh no, we have some kind of interesting off by one error happening here. We can see that 4 and 5 shifted correctly to the front, but something went wrong. Our 3 totally disappeared, and we ended up with a 0 over here. Now this 0 is there because that's actually the uninitialized value from shifted. And that just sort of comes from having done this enough times that I know that that's what that is. Where did 3 go? Well, by the looks of it, 4 and 5 shifted, and 3 actually never shifted, so it just got overwritten by 1. So something went on in our rotate left, and it should be pretty easy to find. Now, if we're really unsure of where to look, we can always do stuff like print out our k elements array. If I print my k elements array right here, I can rerun this, and I can make sure that 1 and 2 are what were pulled in. Oops, I should probably do that after it gets filled, after we fill the k elements array. There we go. So let me try that again. I'll recompile, move everything out of the way for a second, and try to run it. And we can see that k elements does have 1 and 2 in it. Now the next thing we can do is we can say, well, since we know k elements worked, why don't we go and see what shifted ends up having in it after the first filling of shifted. So after we supposedly move 1, 2, and 3 in, while leaving behind 1 and 2. What should shifted look like at this point? Well, what I'm hoping it looks like is 3, 4, 5, 0, 0. And I know that that's not what's going to happen, but it's important for us to still take time to figure out what we're expecting so that we can compare it to what we get and figure out what's going on. So what I can see is while I expected 3, 4, 5, 0, 0, I only got 4, 5, 0, 0, which means my very, very first run through, I'm not grabbing the right element. Okay, so what's going on here? Well, if I go back to my original picture, or at least if I think about my original picture, when my elements were, when k is equal to 2, pardon me, I need to move elements 0 and 1. So if I start this off at k plus 1, I'm going to be missing an element because I end up starting my I off not at index 2, but at index 3. This needed to just be k, not k plus 1. So now I can go ahead and rerun all this and confirm now I am actually getting the right answer, which is awesome, of course. Okay, now what happens if I go and change this value here instead of 2, I make it 12. Do we know what the answer should be? Well, I know what the answer should be, and I can tell you right now that the answer should be 3, 4, 5, 1, 2, just as it currently is. And that's because there are 5 elements in my array. And so when I do k rotations 0 through 4, I'm going to get the exact same array again. 5 through 9, I'm going to get the exact same array again. And then rotation 10 moves 1 over, and rotation 11 moves 2 over. And after my 12 rotations, because I started counting at 0, I end up with the same array. Does it work right now? Let's take a look. Okay, it doesn't. Why doesn't it work is a really good question. Um, but but it's also actually very intuitive. So let's go and look here. It says rotate left main Java 44. We come down to main Java 44. We see the issue is going to be right here, and that's because I starts at 0 and goes up to k. And as we know, k is going to go outside the length of both of these arrays, right? We know that that's going to be a problem. How are we going to solve this problem? How are we going to make it so that we don't run off the end of the array? Well, like we just said, every 5 elements, we know we end up back at the exact same original array. And that's by design. And what that actually is telling us is that we really only care about the remaining k values that don't fit into the length of the array. And we do have a little trick for that. And that trick is to reassign k equal to k. I should probably do it actually to avoid any errors. I should do it inside this if statement. K should be equal to k modulus the array length. So now, if k does happen to be bigger than 5, we're just going to start taking 5s off until we reach the remainder. So 2 modulus 5. Our original value was just 2. And that's why we did our 2 shifts and we ended up with 3, 4, 5, 1, 2. Now if we do 12 modulus 5, we still end up with a remainder of 2. And that's because you can kind of think of it, if you don't know your modulus that well, a bit like it takes 5 apples to make a pie. If I have 12 apples, how many apples will I have left over after I make the maximum number of pies? Well, I'll have 2 apples left over after I've made the maximum number of pies, being 2. And that 2 is my remainder. That is my modulus. So 12 mod 5 is going to give us 2, just like 2 mod 5 gives us 2. So now we only need to do 2 shifts, and our k is going to be appropriately in bounds. So let's go and confirm that this is the case. Let's make sure that we no longer get an array out of bounds exception using the value 12, now that we have a modulus in here correcting our k value to keep it within the bounds. Let's do our compilation. Let's do our final run here. And we can see we do end up with the correct answer. I still have a print statement here. I can get rid of that now. Oops. There's no reason to, whoops, I clicked enter too soon. There's no reason to keep it in there, but we can see our original array and our next array. It's also worth testing some other numbers. For example, if I do array 13, I understand that this should probably shift one more than 12. So this should end up 4, 5, 1, 2, 3. Let's just make sure that that also occurs. There we go. And now we know that we have the right answer. So that's fantastic. Okay, as always, you won't actually find my solution posted anywhere alongside this video. If you watched my walkthrough without actually attempting the problem, you can always stop here, close the solution, and try to write it out yourself now, because a post-walkthrough practice is still worth something. You're also welcome to, of course, now try to solve this problem without the use of extra arrays, so everything should be done in place, and your rotate left method becomes void. If you have any questions about this problem or suggestions for future practice videos, please feel free to leave me a question or a comment in the comment section below. Thanks everyone, and I'll see you in the next video.